Good day, everyone. And once again, we're back together. And today we'll be looking at surds. Otherwise, they are also called rational exponents. If you haven't subscribed, please just make sure that you're part of the family and just hit that subscribe button. And of course, you can hit that notification bell so that you are alerted every time we are posting a new lesson. All right, let's not waste any further time and let's get right into it. Right, now, first of all, let's just talk about surds, or otherwise, as I said, we call them rational exponents. And the reason for that is that what is a surd? Essentially, it's when we have a root of something, right? The nth root of anything, in this case, and we cannot actually simplify it to a whole number, right? So in this case, what we do is we write it in the form a is the nth root of a, exponent m. We can actually say this is a m over n. So it means that in this case, the exponent that is inside becomes the numerator, and of course the root therefore becomes the denominator. That's a way in which we can write an exponent, right? So in this case, or we can write a surd in exponential form. So in this case, if we've got, let's say, just for interest sake, so the nth root of a, so remember that it means that we've got a 1 there. So we can write this as a to the exponent 1 over n. So this becomes very important for us to just remember. Just an example, when we take the square root of the number 4, right? So remember, if we've got a square root, usually we have no number there, right? So by the way, just something for us to remember, when we're using n there, n must be any number that is greater or equal to 2, right? So when we've got a square root of 4, this is the same as with a 2 there. So it means if we wanted to write it in exponential form, so that will be 4 exponent 1. Now remember, we've got a 1 there over 2. So we are raising it to the exponent 1 over 2. Now, ladies and gents, I just want to ask you to be mindful of something. Right. It really helps for you to know your prime numbers. Okay, I'll talk about that a little later on. But if I wanted to actually, just to show you, the square root of 4 we know is 2, but we can write this as a prime base squared. So that's 2 squared. We know 2 squared is 4. But in this case, that is multiplied by 1 over 2. I'm going to talk about the rules in just a bit. And of course, we know that's 2 over 1 multiplied by 1 over 2. So this is the 2's cancel there, and you're left with 2 to the exponent 1. And of course, that gives us 2. So the square root of 2 is 4 in that way, right? Now, I'm going to take another one just before I take you through or just remind you the rules. So if we take the cube root of 100, in fact, let me take negative 125, right? Just note in this case, we're taking the cube root. So it always helps for us to know in this case that, if you put it in the calculator, you will get negative 5 as your answer, right? But in this case, how can we write this in exponential form? So this is going to be negative 125, okay? And this is raised to the exponent. Remember, there's a 1 there, so it means that is going to be 1 over 3, right? Now, to simplify it, what we do is let's break 125 into a prime base, a prime number. But I know in this case that 5 times 5 is 25 times 5, that will give us 125. So that will be negative 5 cubed, right? Multiplied by 1 over 3, right? So in this case, what does this become? Of course, 3 and 1 over 3 cancel, and in that case, you get negative 5. And that's how we are going to solve it. Now, what I want to just simply alert you of, let's go back to the rules in exponents, right? Remember we said if we are multiplying basis in this case, so if I've got a multiplied by b, right, or let me say n, a to the exponent n, b to the exponent m, right, raised to the power c, in this case what do I have? It will be a n multiplied by c, b m multiplied by c. Remember we said that rule, right, when we started with exponents, right? In this case, I want you to note the same can be true when we've got, in this case, surds, right? So if I've got the nth root of a, right, multiplied by the nth root, if the roots are the same of b, I can actually write this as the nth root of a multiplied by b, right? Or you can say ab in this case, right? So I can write that as a product, simply meaning that I can also write this as a multiplied by b 1 over n if I wanted to write it in exponential form. And again, remember, so that would be a 1 over n multiplied by b 1 over n. Okay, I hope that all of you understand that. All right, now in this case, if I go, in this case, we take the division rule, right? So if I've got the nth root, okay, so the nth root of a, okay, let me just write this nicely, the nth root of a over b, right? So what can I write this as? This would be the nth root of a divided by the nth root of b. Now note, in the same way that we can write this, simplify this going that way, we can also actually write it in reverse. Of course, it will depend on what we're trying to simplify, right? So what can we represent this as in terms of exponents? This is the same as a over b, right? 1 over n. If you remember, we said the nth root in this case, we can write it as 1 over n. And so this would be a 1 over n divided by b 1 over n. All right. Now, ladies and gents, I want you to please remember the following. It does help a lot when we know our prime basis, okay? So what are prime numbers? We said these are numbers that are divisible by 1 and themselves. For instance, 2 would be a prime number, right? Why? Because the factors of 2 are 1 and 2. 3 would be a prime number. Why? Because the factors of 3 are 1 and 3, right? 5 would be a prime number. The factors of 5 are 1 and 5, right? So on. So in this case, 9 wouldn't be a prime number, right? So 9 cannot be a prime number. Why? Because its factors are 1, 3, and 9. Can you see? So it's no longer just 1 in itself. We've got an additional number there. In this case, we've got that is not a prime number, right? So now what will help you in surds is always to break numbers down into prime factors. I'm going to show you just that in just a little while, right? So it helps to know that 2 squared, for instance, is 4, right? So whenever I see a 4, right, it is not a prime number in this case. So I can convert it to 2 squared, right? If I see an 8, for instance, then I know 8 is not a prime number. How can I represent it as a prime number? I can actually, a prime base rather, in this case I can write it as 2 cubed, right? So it's important to know those, right? Let's say something like 9, right? How can I write 9 as a prime number? In this case, that would be 3 squared, okay? So it also helps to know that when I write, okay, so of course you can write that as 3 squared. It helps to know that 5 squared is equal to 25, okay? 5 cubed is 125. So remember 5 times 5 times 5. It also just helps to know that 4 squared is 16. Or you can actually even break this down into a prime factor. If I've got 16, 16 would actually be 2 exponent 4, right? In this case, that would give us 16, and my base is a prime base there. So what you simply try to do, ladies and gents, you always try and represent your bases, break them down into prime numbers, right? Now, I'll just make an example. So if I've got, for instance, square root of 12, okay? Right. I know in this case, how would I simplify this? I know that 12, to represent it as with prime basis, would simply be, let's say, 4 multiplied by 3, right? But I know 4 is not a prime number, right? So in this case, I can say, well, this can be square root of 4 multiplied by square root of 3. Now look at this. We're now applying our rule there, right? So we've taken this one here, right? Nth root of a times b, and we've broken down the nth root of a multiplied by the nth root of b. Now, you know, square root of 4, what does that give us? That gives us 2, and multiplied by square root of 3, so that gives us 2 root 3, right? So it helps us to actually simplify them like that. Now, what I want us to do is to take some examples, and we're going to try and apply this in practice. All right, so let's take a couple of examples. So let's say, let's start with example 1. So we're taking square root of 98, right? So in this case, how can we write this as a, in the simplest form, right? So what we do is, we said you work with prime numbers, right? So when I look at it, 98 can be a perfect square multiplied by a prime number, right? So that would be 49 multiplied by 2. 2 is a prime number. 49 is a perfect square, right? So in this case, this 49, that is 7 squared, right? Okay, so the square root of 49 multiplied, what am I doing? The square root of 49 multiplied by the square root of 2, and so square root of 49, that's 7 root of 2. So that's the simplest way that we can write that down, right? Okay, let's take another one. So how can we write the cube root of 8? Okay, so in this case, you can say to me, all right, so cube root of 8, remember, if you take it and put it in the calculator, that's fine. But remember, for those of you particularly who are going to write the NPT, it's important for you to know this. And in university as well, it's very important to know this off by heart, right? So this is 2 cubed, right? And you are saying the cube root of 2 cubed. So in this case, it simply means that you can write this as 2. 3, remember, this becomes the numerator, and that one becomes the denominator. That's 3 over 3. That will give me 2 over, to the exponent 1, and that is equal to 2, right? So the cube root of 8 is 2, right? Okay, so just for us to know how to represent this in exponential form, right? Let's take another example. What if I have got the square root, okay, of the cube root of 8, okay? How can we represent this in exponential form, right? We said we break numbers down into prime factors. So let's start with, okay, let's start with what is outside. That's the square root, right? So remember, it means that we've got the cube root of 8 raised to the power 1 over 2, right? Remember, if we've got a square root, there's a 2 there, okay? So it means that we take everything that is inside, and in this case, it's raised to the exponent 1 over 2, right? So in this case, what I can do is I can change what's on the inside there. So this can be 8, okay? So I'm dealing with this here. So 8 in this case, now I'm going to change that cube root to being 1 over 3, but I also raise it by 1 over 2, okay? So I'm raising an exponent to another exponent. So in this case, this is the same as 8 to the exponent 1 over 6, because when I multiply that, 1 times 1 is 1 and 3 times 2 is 6. So I can simply say that is simply going to be, in fact, let me just write it as a prime base in this case. So that's going to be 2 exponent 3 raised to the exponent 1 over 6. So that would be 2 raised to the exponent 3 over 6. And so remember, that simply becomes 2, right? 3 into itself once, into 6 twice. So you can actually write this back as the square root of 2. Okay, right. I hope that makes sense to you, ladies and gents. Right, now let's take another one. Okay, so I think that's our 4th example, right? And I want you to really get into the gist of this. I'm just using the multiplication rule. I'm going to teach you something, in the next lesson about the addition and subtraction, right? So let's take the 5th root of 96. Okay, so how can I represent this as a simple surd, right? So what I simply do is to say, all right, what is 96? How can I write it as a prime base in this case? All right, now if I think about it, 96 is 32 multiplied by 3. 3 is a prime number, okay? So, just think about it. If I tried to write it as a, let's say if I tried to use the number 2 in this case, I see I was going to have 48 multiplied by 2, but 48 doesn't help me much. It's not a perfect square, right? So that's why I chose 3 instead. So I'm going to say this is the square root of, or rather not square root, the 5th root of 32 multiplied by 3. 32 times 3 will give me 96. So in this case, why am I writing it this way? Because now I will have the 5th root of 32 multiplied by the 5th root of 3, right? So I can simply say, but what is 32? That's going to be the same as 2 exponent 5, right? Multiplied by 1 over 5, right? So if I change that root, becomes 1 over 5. That's multiplied. Why did I say 3 here? It's 5. Sorry about that. So that's 5 multiplied by 3 and 1 over 5. Or if you want to leave it in that format, you may do so. That cancels with that. So in this case, I've got 2, right? Okay, or I can write this as 2 multiplied by the 5th root of 3. That's the simplest way in which I can represent this. Okay, right, the next one. Okay, let's take the next one. So we did number 4 there. Okay, so if I say to you, I take the square root of the square root of 81. Okay, so how can I represent that? All right, so I'm going to say, well, that's the same as the square root. Now I'm going to put this in brackets, right? the square root of 81. Now remember, this first square root becomes 1 over 2, okay? But I can also write this as 81, 1 over 2, and that square root now becomes also 1 over 2 as well, okay? So I took the first square root in this case, right? That became 1 over 2, okay? And in this case, the second square root also is 1 over 2. So what do I get? I get 81 raised to the exponent 1 over 4. But in this case, I can simply say, well, but what is 81? Okay? So if you think about 81, 3 times 3 is 9, times 3 is 27, times 3 is 81. So this would be 3 exponent 4 raised to the exponent 1 over 4. So in this case, that's going to be, well, that cancels with that because it's 4 over 1 times 1 over 4. And in this case, that simply gives us 3. I hope that makes sense, ladies and gents. Okay, so please remember, I'm raising and here I've got the square root of another square root. So both roots in this case simply multiply each other, right? So let's take another one. All right. So what if I write there the cube root of 27 over 250? Right? How can I write this as in the simplest set form? So in this case, 27, okay, I can write this as 3 cubed, right? So think about it. 3 times 3 is 9, times 3, that's 27. Okay. In fact, before I even do that, let's write this as the cube root of 27 divided by the cube root of 250. So remember our rule, right? Our second rule, I think we applied it over there. We said once you've got the nth root of something, you can actually just divide by the nth root of A and the nth root of B. Right, so all I've done was to separate them. And in this case, we know that nth root, the cube root of 27, in this case, that would simply give me 3. Or I can write 27 as 3 cubed, right, raised to the exponent 1 over 3. Right, so I've changed 27 to 3 cubed. But I know that the nth root in this case, or the cube root, would be 1 over 3. And the one at the bottom, when I think about it, that's going to be 2 times 125. And by the way, ladies and gents, don't mind if you see me do this. To some extent, I've got a bit of experience with these things. But the more you do them, the more you kind of figure out how to convert certain numbers. So please don't be alarmed why I would know why I would know what to change to what. Okay, so in this case, I'd say 125. Why? Because I know that 125 is a cube root. The cube root of 125 is 5, right? So in this case, I've got 2 times 125, which is 250. But I know that the cube root is 1 over 3 there, right? So, and at the numerator, I know that the 3's cancel, so I've got 3 there. But at the denominator, I've got 2, 1 over 3, multiplied by, remember I said 5 cubed, in this case is 125. But remember, I still need to say multiplied by 1 over 3. So in this case, what do I have? I've got 3 divided by the cube root of 2. I'm going to write it as the cube root of 2. And in this case, those cancel out, and I'm going to say multiplied by 5. So I have 3 over 5 cube root of 2. Now, ladies and gents, later on I'm going to show you how to rationalize surds, right? So I am going to show you how to do that in the next video, right? Now, the last one, but in this case, I want you guys to do this for yourself, right? Show me how you will actually simplify square root of 144, okay, multiplied by a square root of 5 over the square root of 20. Please just let me know at the, on the comment section how you would simplify something like this. But otherwise, I want to leave the lesson here for now. I'm going to talk about the addition and subtraction of surds and how to deal with that in the next video. Otherwise, from me for now, I'll see you guys next time. Sharp, sharp.